Dear students, I hope you are well. This is your instructor Chem 5 to 4. Today we will discuss microstates. I have already sent you written material on this topic. Today I'm going to send you through this video some explanations of this topic. Microstates, as I have explained you in my previous lectures, are the states in a given configuration. Each atom has its own configuration, and this configuration contains in it a number of microstates. Microstates are the electronic states that are possible from a given electronic configuration. I will explain it through one or two examples. Consider P1 system. There are 3 p orbitals, as you know that, and these 3 orbitals can accommodate maximum 6 electrons. That will also tell us that there are 6 possible ways in 3 empty orbitals. If we have 1 electron, that would mean, if you see it on the slide, there are 6 ways in this one single electron can be accommodated. 1 electron in px orbital with spin up, and in the second with spin up, and then there are 3 ways with spin down. Thus we say overall there are 6 ways in which we can put 1 electron in p orbitals, or in other words, there are 6 microstates in the P1 system. Let's take the example of D1 system. D orbitals, we have 5 d orbitals. Okay, I have shown those here, okay, in this table. And 1 electron, you can say 1 electron with spin up. These are the 5 ways with spin up, and then 5 ways with spin down. So overall there are 10 ways 1 electron can be put in a set of 5 d orbitals. Here I'm going to just brief it. We can say that P1 has 6 ways and D1 has 10 ways, or P1 has 6 microstates and D1 has 10 microstates. In the same way, we can find out how many microstates there are in P2, and it is 15 microstates. In a minute, I will explain you the method how we find it out. Similarly, there are 45 microstates in D2 system. The formula for finding microstates is shown here. Number of microstates, capital N, is equal to n factorial divided by R multiplied by n minus R factorial. These terms, capital N, small n, and R, are explained. Capital N is number of microstates, small n is maximum possible electrons in the orbital, and R is maximum number of electrons in the orbital. Now I think I will be able to explain this with the help of example. First of all, we have seen there are 6 microstates in P1. So what we do is 6 factorial divided by 1 factorial and then multiplied by 6 minus 1 factorial, which is equal to 6 factorial multiplied by 5 factorial. Factorials, what is factorial? Factorial is simply 6 factorial means start 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. From 6 to 1 is just multiplier. And similarly 5 factorial means 5 multiplied by 4, go in descending order till 1. So if you do this, you multiply, the answer is 6. This is what we had seen in the table before. Similarly, let me write the configuration of carbon. Carbon has 6 atomic number. So its configuration is 1s2, 2s2, 2p6. You people are very familiar about the configuration and how to write it. Okay, we know very well how many maximum, the value of for small n is 6 here, how many maximum electron or how many ways, one electron with that is 6. So what will, there are 2 electrons in the p orbital. So then it is 2 factorial and then 6 minus 2. Okay, 6 is the maximum possible electrons which can go, which is 6 in the p orbital, and 2 is the number of electrons which you can see here. It's a p2 system. So this 2 comes from here and rest is 6 minus 2 factorial. And when you do this, you have